Water holding capacity of biochar from eucalyptus wood. The use of waste from charcoal production is a way to integrate waste management with environmentally friendly practices and potentially improve the water holding capacity of growing medium soils. According to researchers, biochar has a high capacity to retain water due to high amount of small pores. It may have an effect also to reduce pollutants and reduce the contamination of groundwater. This study evaluated the water holding capacity from two different size fractions of biochar from eucalyptus wood. The values of the moisture and the study potential for soils are considered to be field capacity moisture. The sample of biochar from eucalyptus wood was provided by a production unit of charcoal for steel industry. The samples were prepared using two sieves for standardization, using the fractions smaller than 1 mm and the fraction between 1 mm and 2 mm. Samples of industrial sand was used to mixture with biochar using 10%, 25%, 50%, and 100% biochar. The samples were conditioned in volumetric cylinders in triplicate and then saturated with the aerated water from bottom to top by capillarity. The retention was determined at specific potentials using a kaolin tensile table connected to a vacuum pump for 3 potentials. The evaluation was done after the samples reached their hydraulic equilibrium, verified by weighting the samples until no changes in weight was verified. Then the samples were then weighted and dried in an oven at 105 degrees Celsius for determination of the moisture. Figure 1 shows the volumetric water content at equilibrium with 6 kilopascals. In mixtures with 10% and 25% of biochar, there was no significant difference in retention as a function of grain size. In the sample with mixture of 50% and pure biochar, the particle size show a great effect on the water retention capacity, with samples of a lower particle size holding more water. The resulted potential of 10 kilopascals showed higher volumetric water content in the samples and mixtures with biochar of smaller size. The moisture in evaluations made at this potential in tropical soils is often called field capacity. It has a direct relationship with a balance between the retention force of capillarity and adsorption against the gravitational force. According to studies, field capacity of 33 kilopascals is used in soil samples from temperate regions. Figure 3 shows that at 33 kilopascal potential, the moisture is lower than pure sand for the coarse biochar for 50% and pure biochar. It must be investigated just because biochar water holding capacity based on mass may hold more than 100% of their weight in water. As conclusions, there is a greater moisture by biochar as thin particles and its mixtures with sand at 6 and 10 kilopascals potentials. Greater moisture in biochar and sand mixtures biochar with smaller particle size is due to an increase in fine pore in specific surface area and due to increases the amount of water adsorbed on the solid surface and in micropores. This correlation was observed for all 3 potentials studied, and the recommendation of one of these potential to be used as field capacity will depend on further studies and a specific definition of field capacity for biochar or mixed substrate biochar samples.